State University, and welcome. And welcome to the second annual Distinguished Lecturer in Business Ethics presented by the School of Business here at Middle Georgia State University. Now, we inaugurated this lecture last year, so it is like the second annual, and we're committed to its continuation. And for three different reasons. First of all, we strive to equip our students with the ability to recognize and act on an ethical dilemma. We teach business ethics actively in the School of Business, and we seek every opportunity to bring this discussion into the classroom. It's important. It's incredibly important. And that's my second reason, is that ethics are essential to the business world. Both profit and nonprofit entities that prioritize ethical decision-making and ethical integrity, they find themselves talking to us. How about now? Is that better? All right. How about now? No, you can't hear me at all. All right, perfect. All right, so ethics are essential to the business world. Both profit and nonprofit entities, if they prioritize ethical integrity, they often find that they're not only respected, but they also are more effective, more efficient, and more profitable. Now, while I mostly subscribe to Milton Friedman's view of the firm, it's important to clarify that his doctrine is often a little bit misunderstood. He advocated for the pursuit of profit within its framework of respect for others' liberty, adherence to the law, and a commitment to social responsibility. His philosophy does not promote an unchecked drive for profit. You have to be ethical. You have to be ethical in all that you do. And finally, the third reason of why we think that this is important is that, and I think it's probably the most important, is that ethics are vital to the reputation and careers of individuals in business. I'm reminded when I first started a similar type of series at Augusta, as I'm reminded of an article that came out on that day that we started this series, and it wasn't planned, it was pure serendipity. The front page of the Atlanta Business Journal, the Atlanta Journal-Constitution, on their business section, had the pictures of 12 executives. And these were amazing people who had achieved incredible success. They were titans of the industry. They were innovators. Their academic credentials were flawless. And they led companies that made significant economic contributions. There was one thing that they also had in common, and that was all 12 were either in jail or on their way to jail. So what went wrong? How did these smart, accomplished people become felons? To become criminals and fall from public grace? I don't have a definitive answer, but I know this, that if today's lecture influences just one person in this room to think through the next thing that they do that causes them to think about an ethical decision, that we've made a meaningful impact. So bringing in distinguished lecturers like Doug Miller.
Sorry about that, boss.
So bringing in distinguished lecturers like Dr. Doug Miller allows us to explore these issues. It allows us to think about them from fresh perspectives. And without this kind of dialogue, we risk slipping into these terrible decisions. We risk slipping into ethical complacency, a place that none of us ever wants to go. So, with that, it is my pleasure to introduce today's distinguished speaker, Dr. Douglas Miller. Now, whom I'm proud not only to call a friend, but we go back a long way. As a matter of fact, we were both deans in Augusta, Georgia. He was at the College of Medicine at the Medical College of Georgia, now Augusta University, and I at the Hull College of Business at then Augusta State University. And so there were two Dean Millers in Augusta. And sometimes people did confuse us, but I would tell them it's easy to tell us apart, is that he's the smart, good-looking one, and I'm the other one. Yeah, so yeah, some of them would laugh, and others just simply nodded and say, well, that makes sense. Thank you for clarifying that. But Dr. Miller, Dean Miller, Doug is uniquely accomplished, having served over a decade as a dean of three research intensive medical schools in the U.S. and Canada, and he's also overseen successful med tech incubators. He's a cardiologist also. That he's trained at Emory University and Harvard, and he still finds time to see patients on a weekly basis. Even when he was dean, he was seeing patients. So he sees things in both a macro point of view. He has an MBA, that's a good thing. He also has an MD and an empathetic nature, so he sees things in a micro level as well. He's a strategic thinker. He holds that MBA from St. Louis University and executive education credentials from UC Berkeley and from Harvard Business School. He serves on boards of several global health policy and biomedical business organizations. He's an entrepreneur at heart. He holds 3 patents in pharmaceutical R&D, medical imaging, and our subject today, artificial intelligence. So I'm confident that you'll find his talk today both enlightening and thought-provoking. So please help me give a warm Middle Georgia welcome to Dr. Douglas Miller. Thank you. Thank you, sir.
Thank you very much, Mark. It's a pleasure to be here with you today, and it's a testimony to the fact that he can raise an audience at 3 o'clock in the afternoon on the election day, that we're all here. But thank you for that. Yeah, and I enjoyed the drive over from Augusta this morning, and saw Monticello for the first time, which was quite nice. Saw I-75 again for the last time, I hope. But nice to be here at your lovely college. So yeah, ethics in business and ethics in medicine and ethics in any field you're in are obviously very important. And whenever you're confronted with rapid change or rapid technology advancement, it tests the system's capacity to manage itself and to regulate itself and to understand exactly what it's doing in real time, because in fact, things are happening so quickly. And we were chatting over lunch with some colleagues about what it was like to go through COVID, right? When we really didn't know what was happening, and whether you were in business that was being shut down, or whether you were in medicine and didn't know how to treat these people, or in public health and didn't know whether to send kids to school or not. There are times in our lives when we are confronted with a lot of moving parts. And that's when your ethical principles and how you think about them are probably the most valuable, because there are things that feel right or that aren't right, and you can sort of sense it and know it. So I'm going to impart to you today my sense of the field of AI in healthcare as an example of how we are tested in our way of doing business. You each have your own examples of this in education and other areas and pursuits. But it is a unique time, and we do, I think, have to arm ourselves with a little bit of understanding and then think about how we feel about what is going on around us so that we can then confront or adapt to whatever's happening, right? There doesn't have to be a bad thing, doesn't have to be a good thing, but confronting and adapting probably are helpful and healthy. So let's see if I can make a slide projector work. So, is AI healthcare compatible? What I'm trying to say is, I'll make the case over the next 45 minutes, is something about a technology and healthcare could be compatible and could help us to take better care of patients, or create a better patient experience, or to improve the way we deliver something that's a logistical sort of part of healthcare. But bringing the two together and sort of banging them together into a fit function that may not be well understood can also be harmful. And the harm that occurs in this case isn't just a harm to a bottom line of a company or to a logistical problem in some shipping venue, but it actually could affect patients' lives and cost people their lives. And so as a responsibility, physicians say, and they take the Hippocratic Oath, it will do no harm, right? That's what primum non nocere. We have all got the responsibility to do no harm. Just because we have it in an oath, and perhaps your field doesn't, we all have that responsibility. So understanding compatibility and functionality and adaptability and all these things in your own field when it comes to AI and whatever you do, are they compatible? The answer is yes, but there needs to be an understanding of where we have to draw some lines or create some parameters by which we try to work to make it compatible. So I want to point out in the beginning, in the history of AI, and AI, all of you probably have your own idea what that means, right? But it begins with computer code, or algorithms, as they're commonly known, causing a machine, a computer these days, to produce a function, right? And that function could be things we'll talk about in the modern era of deep learning. But back in the day, in the 1830s and 1820s, Ada Lovelace, who was the daughter of Lord Byron, the poet, who left the family a month after she was born, became a precocious programmer, or mathematician, and created this code called Note G to actually instruct this machine, Charles Babbage's analytic engine, how to work. And although the code was never actually applied to see the machine work in the real world, it was designed to cause this machine to function in a very complex way as Charles Babbage had designed it. So it was the first algorithm. And those instructions that you give to a machine to do something, no matter how you write them, Python or whatever you write in, are what tell the machine what to do. So I wanted to start with this because in the beginning and today, whatever magic you see coming out of AI, it begins with code. There are people writing code. And the more people you have writing code and the more powerful your chips are and the more compute time you've got, the more you can do with that. Okay, so I just wanted to kind of remind us of that. Now, anybody see The Imitation Game? Okay, it was a pretty good movie. It was about Alan Turing, who lived between 1912 and 1954, who was basically credited with the invention of computable numbers and machines, kind of early AI. He's the presumed father of AI. He created machines like the Turing machine here. He also created the Enigma machine. It was used to break code in the Second World War, he and his colleagues. And he solved this German math problem as well back in 1936, and was basically kind of credited at that time with being the father of the AI, the first AI era, or the first computer era. So, interestingly, he died young of suicide because homosexuality was illegal in England up until the 1960s. Illegal. But anyways, that's a separate issue, ethical. The real breakthroughs that occurred in artificial intelligence, and there were many things that were done before this happened, and I'm going to take my privilege as a Canadian to point out a few Canadian computer scientists that were actually very important in the field of AI. And this is the work of Geoffrey Hinton and his colleagues at the University of Toronto, published in 2006, where he basically coined and used the terms that went on to become deep learning. He created algorithms, which are layers of compute neurons that connect to nodes and basically go through different processes of computation. And in this particular experiment, as he summarizes, we have shown that it is possible to learn a deep, densely connected belief network, one layer at a time, moving forward. The obvious way to do this is to assume that the higher layers do not exist when learning the lower layers. Now, that's a lot of words, and the concept here is that you can take, once again, as always is the case with AI, many inputs, complex unknowns, but the machine can study and train on those inputs, data, whatever it may be, in this case, ciphers, if you will, or figures, and can go through different layers of compute to come up with fewer options as solutions with a low error rate, in this case 1.25%, which for the era of 2006 was actually quite low. Right now, it would not be acceptable to have a 1.25% error rate, but in day, that was a very low error rate, and come up with a generative model that created a solution which basically lined up these numbers in the correct order, in the correct way. So, Geoff Hinton went off to work at Google, and Geoff Hinton came out of Google in 2023 because he was so concerned about where the field of AI was going. He had his own ethical concerns that caused him to leave Google, and he won this year's Nobel Prize in Physics, which we'll talk about in a few minutes. So I don't know how much of his work in 2006 and before, when he created the Boltzmann machine back in 1983, actually contributed to his Nobel Prize, but I think his ethical stand about AI in the modern era and his concerns, which I'll show you in a few slides, actually may have contributed to the luster by which the Nobel Prize Committee saw him and his work. How many people remember this? So AI's won some games, and in 2011 it won, a good game of Watson played Jeopardy and actually won against the two best human contestants that have ever played Jeopardy. You can see Watson's got $36,000 and they got $5,000 and $2,000, and Watson just killed these guys. So when I went to be the dean at New York Medical College in Westchester, New York, it's a very bucolic little community. It's in Westchester, kind of a high end, and there's a building that we bought from IBM, and at the time that I first saw that building, I didn't realize that it was the building where they trained Watson to win Jeopardy. And I'll tell you a story about Eric Brown, who I met eventually at the Watson Research headquarters in Yorktown Heights, New York. But it was just funny to walk into a building that was now a medical school building where they trained Watson to win Jeopardy. When Eric and his colleagues trained Watson, all these computer scientists, to win Jeopardy using a form of natural language processing that they called Deep QA, they had to teach it sort of a funny way to think as a natural language processing algorithm. But they got it to be able to answer questions quickly and frame them as questions, so answers become questions in Jeopardy, as you know. They went through all the improvements they could in the Deep QA process, and eventually when they got to 73% of what they thought was maximum on the leaderboard that they were creating, they said, let's play Jeopardy. So it wasn't perfect. It was 73% ready in their view after starting at 32, and then next month it was 43, and it went up like that on the leaderboard. But when they got to 73, they said, let's play, and they killed the humans. I mean, not literally, they still live. One of them hosts a game show right now. And during the show, it made a lot of really stupid mistakes. It didn't get everything right. It answered this question with what is Toronto when it's O'Hare, and what are you going to do? Anyway, but nonetheless, it was good enough to go. Now, let's fast forward a little bit for a few years. Once again, I know you know this, but so much has happened in 10 years or 15 years that it's amazing. The pace at which this technology has been propagated and understood and applied has been just remarkable. This is, this is Ian Goodfellow. I think he was 12 at the time. No, he was a graduate student working at the Université de Montréal. And he was working with Dr. Bengio and others. And he wanted to sort of test the idea that at the time that these deep learning artificial intelligence machines were actually perfectly accurate, that they were so powerful that they couldn't be fooled, basically. So you have an original image file of pandas on the left there, and the machine would go through multiple layers of neural network computation and solving, and eventually it would get to a 57.7% likelihood that it could predict a panda face. And there were other places doing this with cat faces, you may remember those, right? Anyways, in their model, they got to 57.7% confidence that it was a panda, which is not high, right? But it's enough, okay? It's a good network at the time. He then introduced this distortion called the nematode in the code, which basically changed it by just a little bit. And by changing it a little bit, he created a new algorithm and a solution through the neural network that the machine was now 99.3% confident that it was a gibbon. He was 100% confident of his mistake with a slight disruption. And this is where the computer science and common sense of AI came together for the first time. I can put a little bit of a glitch in there. It could be me not programming something correctly. It could be you having a bias about what you're doing. It could be any number of little tweaky things that we can do. But you can change that machine from being pretty good at predicting the truth to being 100% certain it's predicting the complete false image, right? That's brilliant. He went to work at Google too. He still works there. He still looks like he's 12. They dressed him up a little better, but still looks like he's 12. So his boss, Dr. Bengio, Yoshua Bengio, has been at the Université de Montréal for a long time. He will probably win the Nobel Prize eventually himself. But he, in this very elegant paragraph or two, which I will let you read on your own, he pointed out that there is information inside data matrices, complex dynamic data matrices, time series data matrices, whatever kind of data you've got that's complex and hard to deconvolute. If you drop a DL algorithm on that very, very hard for us to understand information, you will come up with insights that you wouldn't have been able to predict without that machine's assistance. Decomposing matrices is what shows us information about their functional properties that is not obvious from the representation of the matrix as an array of elements. This is where data science and computer science come together, right? Because computer science is really good at well-organized, easy to sort of understand data files, right? But the real power of deep learning is that it can take a gamish, as we would say in New York, of data, and it can figure something out that's a pattern that was not visible to humans. And those insights that come out of that can be helpful, or they can be spurious, and you have to be able to distinguish between the two. Because an insight that tells you something is going to happen, a predictive model, let's say, that is powerful, powered by a deep learning laboratory, can be dead wrong. It's up to us humans to be able to vet and validate those models for their reasonableness, essentially. So that's what we need to think about as we go forward. So here's an example of how 2016 machine learning localizes diabetic retinopathy. So when people get diabetes, they get changes in their eyes. The blood vessels become ruptured, they create hemorrhages, they create exudates of protein into the retinal tissue. And ophthalmologists take pictures of these, and they look at them and score them manually, essentially, or with a bit of assistance. And they kind of look at the distribution and say, that's a little bit of diabetic retinopathy, it's mostly exudative, it's mostly hemorrhagic, it's both. And they do this all the time, right? But this was the first study from Google DeepMind, published in JAMA, the Journal of the American Medical Association, in 2016, that showed a machine could do it for an ophthalmologist and achieve the same degree of accuracy as the ophthalmologist was achieving. What could be wrong with that? If it helps the ophthalmologist, if it makes it faster, easier, if it's accurate and it works. So this is machine learning. As one of my colleagues used to say in one of my companies that's now I'm kind of like out of business, he said, machine learning is what I learned in high school. There's nothing special about machine learning. Deep learning, on the other hand, is cool. So this was approved by the FDA in 2018. Google Research developed this at Verily Life Sciences. And what it shows you is a retinal image in the upper left. That's an original retinal image. And then using deep learning as your tool for looking at the vessels, you can predict all sorts of things about the patient just from the vasculature in the picture. You can predict the patient's age. You can predict the patient's diabetic and what their hemoglobin A1C is. That's a measure of diabetes. You can predict how much they weigh. You can predict whether they're female or male, whether they're a smoker or non-smoker, and what their blood pressure is from a retinal image. Now that's cool, and you didn't learn that in high school. This was approved by the FDA in 2018, and in the period of time from 2017 to the present, to a JAMA article last week, the FDA, according to Rob Califf, has approved over 1,000 such AI applications for healthcare, okay? So we'll take a look at some of those, but this is one of the early ones that was approved, and it shows you that you can do some cool things with this. We're going to talk about, though, the fact that when you try to take this type of analysis and apply it in rural India to look for diabetic retinopathy, will that work or won't it? So the people at Google said, why don't we be good folks? There's a lot of diabetes that's undiagnosed in India, in rural India. They don't have cool stuff like we do. Let's give them cool stuff and let them use this for free. And what could be wrong with that? Anybody know this story? So the story is that they gave them this tool for free. Go forth, detect diabetes. They snapped pictures with their iPhones or their cellular phones, and the software didn't work at all. Why would that be? Because the technology was developed for FDA approval using photographs taken in Mountain View, California ophthalmology offices with high-fidelity cameras, digital cameras, and that's not a high-fidelity digital camera. So it didn't work. So they had to retool the whole thing, right? And now there is a tool that works in rural India to detect diabetes, but it was a good example of the hubris of companies saying, look, FDA approved this, we'll give it away. What could be wrong with this? Well, it just didn't work. Interesting. So this graphic that I put into this presentation is a kind of a messy graphic. It shows all the medical device approvals by the FDA from 2016 to 2020. 3 points that I wanted to make. First of all, in the first 4 years, this is everything. This is 40, I think, FDA approvals of software as a medical device. That's what they call AI applications of this type, right? Since then, there have been 950. So the rate of development of these narrow AI technologies, largely for applications in cardiology and radiology, but you can see them other things in oncology as well. The one that I talked to you about from 2018 was developed by a company called IDX. That's the one that we showed about the diabetic retinopathy pictures, but there have been plenty of other applications. I'll come back to this in a bit. All right, so you're asking yourself, what in the world does Doug Miller know about this, and why should he be involved and standing before you today on Election Day, keeping you from a cocktail perhaps later this afternoon? So when I was the dean at New York Medical College, in the buildings near where they invented Watson to play Jeopardy, we also had medical students that did internships at Yorktown Heights IBM research facility. Now, when you walk into this research facility in Yorktown Heights, it's 20 miles north up the Hudson Valley. It's a beautiful drive from where our medical school was. And we had an internship program there for the students that didn't finish on time, i.e. not our best medical students. And they were up there helping IBM to do software validation for medical applications. So it's fine. It was a good experience. It helped them get back into the flow of things. It got them better letters to go on to be interns and residents. But I went with my associate dean for medical education up to visit the folks up there, and you walk in the door and there's the Presidential Award for Big Blue and the Presidential Award for Watson and the Presidential Awards for all the things that they do. There are 3,000 computer scientists working at that facility. 3,000. And they're good. And you walk in the place, you sit down, you fill in, you get a card, you go to see, and went to meet Eric, who's a very smart, pleasant guy who I've gotten to know really well. And he says, you know what, it's such a pleasure to have you here because, and this is where it gets so ironic, we have all the answers, we just don't have the questions. We don't know what questions to ask of this technology. You're an expert. We need people like you to ask us the questions to the answers. So we wrote this paper on that riff, and it was published and got some coverage, but the point we were making, though, is the best way experts in the field can help computer scientists is to talk to them. They got all this cool technology. They got 3,000 guys that talk to each other. They don't know what the heck they're talking about if it comes to a healthcare application. But if you go in and say, I need a tool for this, or I need something that can accomplish that, they're potentiated in that way. And so we began having discussions about how to use this capability that Watson has in a variety of different applications in healthcare and in education, and I served on a board of theirs in clinical studies, and you get to know them a little bit. It was a good experience, and I think points to the fact that it takes people like us to help potentiate what these brilliant computer scientists do, and if they work in a vacuum, they're not as good as they can be, I guess. So, in terms of medical applications of artificial intelligence or artificial neural networks, the first time I was exposed to this is when I was a cardiology fellow at Emory, and I was on call. I just gotten there from Canada, so I didn't speak Southern. And I was there at Grady Hospital, and I was on call for the weekend. One of the jobs you had was to overread the electrocardiograms. How many of you had an electrocardiogram? Okay, so the stuff on here generates these curves. Nobody really knows what they are, but they mean things to cardiologists. And the various parts of the QRS complex and the ST segments that follow when repolarization of the myocardium occurs after depolarization are all, you can measure. Look, it's little stuff you can measure on this. There's a lot of things. There's a lot of ups and downs. And so I went through, it took me 3 hours to go through and overread these EKGs. And I changed this, and I crossed this out, and I put in new diagnoses, and I put them on the desk of the head of cardiology the next morning, Bob Schlant, on Monday morning, and he called me to the office, and I thought he was going to say, great job, Doug. And what he said was, great job, Doug, but generally the computer's right, so don't be changing stuff. We just got this new program. It works. Anyways, the point of this is that you can take multiple EKG inputs and data and transitional information and dynamic stuff, and you get one output, which is a normal EKG. And that's powerful, right? If a machine can tell you something's normal and you didn't already know it, that's a powerful tool, and it potentiates you. Published in New England Journal of Medicine in 1991, have been using this kind of technology with improvements ever since then. Now, on an article I reviewed for the European Heart Journal last year, you can take electrocardiograms, which are these little, I'm not sure you can see that. V1 is one of the leads right here when you do the EKG. That's V1, okay? And you get 2, 3, 4, 5, 6, right? So V1 in patients with heart disease looks different. And you can see 4 different patterns in V1. You can go from one to the other, and you can take that information in V1 from an electrocardiogram in patients that are undergoing a procedure called cardiac resynchronization therapy. And you can use that information in that lead to predict what their likelihood of a cardiac event is going to be. So V1 blue has the best survival over 8 years after this therapeutic maneuver. V green, the next level of survival curves, has the next best survival. The worst survival is those in the V1 pattern who can be seen to have a very poor survival, less than 20% over 8 years. The point is that I get manuscripts to review like this all the time in good journals. Electrocardiogram can predict coronary vessel that's affected by disease, the percent stenosis, the likelihood of events. It's just a bunch of squiggles. It's not profound, but the DL on top of this can actually come up with some very slick information and can give you more of an electrocardiogram than you ever imagined besides being normal or abnormal, okay? Deep insights into the prognosis of a patient. Here's another example of what DL can do. This is from the National Institute of Health, NIH. This investigator published this in 2017, and he basically, I'll show you on the next slide, used algorithms and heat mapping to come up with patterns that would allow him to distinguish, using the software, the algorithm, different patterns of disease on a chest x-ray. Now, soon after this, Jeffrey Hinton said we should stop training radiologists right now. Probably that's not good news for radiologists. But this technology basically takes a representative set of images, which you load into the system. You train it through the ImageNet pre-trained models that you can choose from. There's any number of 4 you can use. You put it through a variety of predictive and transitional layers and come up with a heat map, which allows for localization and characterization from a chest x-ray, and which is as accurate as a radiologist, okay? Now, can a radiologist still read a chest x-ray? Can it still make a determination? Yes, they can. But if they were aided by a technology like this, that could improve their efficiency and possibly even their accuracy over time. And in fact, this article published in the British Medical Journal that I reviewed back in 22 shows, and I'm just going to summarize this for you, that for AI analysis of images on the radiology Royal College examination that residents take to become consultants in radiology, if you take the same questions and ask the radiology candidates to solve them and then ask the AI to solve them, the AI does pretty well in terms of sensitivity, specificity, and accuracy compared to those radiology candidates. Now, the receiver operator characteristic curve here is kind of funny and hard to read, but what they're trying to illustrate is that they're in about the same range of ROC curve whether you're taking these radiology candidates or the best model for the AI. I think this was a humorous article. I think it was tongue-in-cheek because it was in the annual part of the British Medical Journal that occurs around Christmas every year, and I think they take a bit of license with what they publish. But it is kind of provocative that this model was able to solve with accuracy comparable to radiology candidates. Now, one other thing that you may have heard of, which I wanted to just mention, which is another ethical dilemma, right, is what do you do with a black box model? Have you heard of a black box model? You put data in, the machine works the data and makes a predictive recommendation, and it doesn't really tell you how it got to the recommendation. So here's an example, a black box model, picture there, data goes in, algorithm head takes over, results are spewed out. This is an insect. Take it or leave it. This is what we're telling you it is. Explainable AI takes the same data set, the same algorithms, but also goes through a process of doing further analysis to determine the basis for its prediction that it's an insect. It's still the same prediction, but there's an insight or an understanding which is explainable. You can explain it to a person that's interested in insects, right? How did you know it was an insect? Well, I looked at the legs and all that stuff, right? So how would you decide and how would you use a black box model that's explainable or unexplainable? Would you be likely, raise your hands if you'd be likely to be more influenced by an explainable AI model? Of course. How many people would just buy the black box unexplainable model? No, just kidding. So, sure, human nature would tell you that you would like an explanation. You would be able to action an explanation, change your decision based on an explanation. Ironically, and this is a good paper to look at, all the research that's out there shows that it doesn't matter whether you have an explainable or an unexplainable model, it doesn't affect human decision making in the real world. Now, it's a fluid field. It's a field where research continues and should be continued because a lot of the explanations or insights that we get from AI are not apparent or explainable in the purest way. So I just want to introduce this to you because if you get a recommendation from a black box model that says this person's got a genetic disease and they need further counseling and testing and their family members need to be advised about this, that's disruptive and scary and harmful potentially. And you should be able to explain to a patient how you got to that information. All right? So the ethical aspects of that are that if you're going to use AI, is it explainable or unexplainable, number one? And number two, can you actually, in your role as the caregiver, give the person information that's informed enough to make a decision, even though the literature says you're not influencing that much? And can you then justify what you're doing with that information about the model's provenance? So I wrote this article in 2018 for the American Journal of Medicine. It was about big data and how we use it, and this was a very early representation of a recursive neural network for natural language processing, which before generative AI models in 2017, initially BERT from Google, before that, this was all there was. And you had this very clunky one word forward, one word back way of taking a picture, extracting a feature using a convolutional neural network, and then looking at predictions in the next word in the sentence would be, and basically you after time, you would get to a plant with a pink flower and a brown stem. Now, that's 2017. That's state of the art in 2017. Word forward, word back, solve, predict the next word, always going forward. 2017. And then BERT came along, and the world changed forever. Now, we have large language models, or generative AI, and we have two companies primarily, although other ones are entering the field all the time, OpenAI, led by Sam Altman still, and Google AI, led by Sundar Pichai. And there have been iterations of these translational models, transformational models, whatever you want to call them, but these are called large language models, and they train themselves on large numbers of parameters, words, texts, scraped from wherever the source is, and they eventually come up with the ability to generate text, and they can calculate forward and backward translation of large tokens or groups of words that make it much faster and much more powerful than it used to be when it was just natural language processing. These models have grown dramatically from BERT in 2017 to GPT-4 in 2023, and GPT-4 was trained on 1.8 trillion parameters. Now, you still had generative models when you had BERT, and it could do what it could do, but the more parameters you train a model on, the more powerful it becomes, and the less prone to hallucination it becomes. So GPT-4 is much less prone to hallucination than GPT-3, for example, all right? But this growth in the number of parameters is just amazing, right? I mean, and it takes, as you'll see, it takes time, but not as much time as it used to take, and it takes energy, I mean power, to do this. So I think I show this, when I made this graph, I sort of said, wow, that's really a lot of parameters. Now, the funny article here, and this is a good article for you to try to find, and it is published, although it was presented at an event in 2021 by Emily Bender and colleagues, is they sort of said, are deep language models real, or are they stochastic parrots? Are they just parroting back what it is that people feed into them, and they really don't know what they're telling you? And they said, in fact, that's often the case, that the outputs of deep language models are so full of technical biases when you're trying to optimize the model and get it to finalize, or so full of human biases that they don't even know that they have when they're entering the data, that you can end up with a stochastic parrot that just, brings back to you what it's heard and really isn't giving you any new insights. And what is the plural of parrots if you have a group of parrots? I'm taking the level of the game. It's a pandemonium. It's even worse than stochastic parrots. It's a stochastic pandemonium. So anyways, I think the point I wanted to make anyways is that these are becoming incredibly powerful generative AI models. So powerful that in 2022, in this article that was co-authored by ChatGPT after Dr. Kung, it showed that it could take a GPT 3.5 and pass the US medical licensing examination at a rate that was comparable to humans. And although it just passed, it just barely passed, it did pass. And the interesting thing here is that they did do this experiment on 305 out of the 376 available questions, because the other 71 questions would have fooled the GPT 3.5, right? So they culled out the ones that would be hard for the machine to solve, but the headline from this is, if you don't read the article in detail, it's just as good as humans at passing the medical licensing exam, all three parts, 1, 2, and 3. I cannot tell you how much student anxiety goes into passing the USMLE exams, Part 1, Part 2, and Part 3. You can imagine high-performing students, it's all they live for. The scores mean that if they get a 250 or above, they can be an orthopedic surgeon. If they get a 250 or below, they have to go into family practice. I don't know. But there's a lot of stakes in this game. But this just pointed out that the machine could actually emulate humans in this regard. This is actually a picture of Leopold Aschenbrenner. And before I Googled his picture, I thought he was probably my age, might have had graying hair, thinning hair. The guy's another 12-year-old, okay? He used to work at OpenAI. He's actually been a whistleblower at OpenAI. So what he did come up with was this really cool graph that shows the compute power effectively between 2018 and a projection to 2028, with GPT-4 being the normal line there, the horizontal dotted line. And what he's saying is that the growth in compute power from language models has been dramatic, right, over the course of the last 2018 through 2024, or 23, 24. And he said if it continues to grow in this regard, we'll be approaching artificial general intelligence, or AGI, by 2028. Now, AGI is the point at which, as it says here, the machine's working as well as an AI engineer or researcher. It's much better than a smart high school or a GPT-4, right? So that's when machines become as powerful as computing and problem-solving tools as humans, the best of humans. 2028. And I think that just is consistent with good science on his part, as well as the idea that we are getting closer than we thought we were going to get to that AGI world, faster than we thought we were going to get there. The other part of this slide that's really important is I got to use that pen highlighter thing. See that? That was 4th try. It's not perfect, but it's good enough for government work. GPT-5 is coming. It's called Orion. It will be released by OpenAI probably early in 2025. It'll be hosted on Microsoft Azure. It's going to be 100 times more powerful than GPT-4. So that's coming down the pike. The speed at which this is occurring is dramatic, scary, and it's unregulated, right? We're going to talk about that. Here's a person who I don't know, but I took her picture and put it on the slide because she said this. When she made a comment to ChatGPT-3, draft me a letter asking for prior authorization to order apixaban, which is a blood thinner, to treat insomnia, GPT-3 responded, why sure, recent studies found that apixaban indeed had the potential to improve sleep. A total hallucination, okay? She asked the same question of GPT-4, and it said it would be unethical and inappropriate for me to draft such a request, a scolding. That's progress. The rate of hallucination of GPT 4.0 is about 3%. It can still hallucinate, but it's much more likely to give you a stern rebuke to your request than you would have guessed in the past. Large language models do hallucinate. This is a picture on the right of an image, and GPT-4, you know, can do images and words, right? And this is a GPT-4 sequence of 3 different individuals' images where it's learning from its own mistakes, essentially, and it's distorting the picture so dramatically that the picture, after 5 iterations of distortion, doesn't even look like the picture you started with at all, right? You couldn't say that this is Juan or not, right? And so this was pointed out in this Nature editorial as being something you need to be aware of, that generative AI also learns from its mistakes. And so by learning text or pictures the wrong way, it can give you a very distorted view of the world. Now, if you've ever had a GPT interaction, you'll know that you can get a hallucination back, and the rates are between 3 and 27% for these 2 models that are widely touted by those companies. The best non-OpenAI hallucination rate is Meta's 70 billion parameter Lambda 2 at 5.1%. The more parameters, the less hallucinations occur typically in the same model. So it's like Palm, I won't go into the details, but there are improvements that can be made and are being made to the credit of those companies. Large language models, fakery foiled. Generative AI text needs to be watermarked. There's a huge amount of work being done. This is a nice paper published in Nature not too long ago, showing that using this technology, which I won't go into the details in, but using something called tournament sampling as opposed to usual sampling, you can actually place an electronic computer watermark on a piece of text that identifies it as being generated by a ChatGPT or generative AI. We have to do this, right? As educators, you would want to know, even if you didn't disparage it, that the paper that your person's giving you, your student's giving you, is generative. Doesn't mean you didn't want that. We talked about that at lunch, right? There's good reasons to do that or improve upon that. But being able to watermark something electronically now is possible. And there's a big effort at Google DeepMind to do this, and this is going to be now part of the next iteration of generative AI capabilities. I don't know how many people know this. I think you're starting to hear about this, but NVIDIA and other companies that make chips, but NVIDIA is the biggest chip maker. Those chips, especially the current versions of them, are big power hogs, right? They use a lot of power to compute. And if you line up thousands of NVIDIA B200 GPUs, or their more advanced model, the GB200, which has a CPU involved as well, and you put all those together into a big computer and you crank for weeks, that's a lot of power being used. GPT-3 training used the amount of electricity by 130 US houses per year just to do a training run on a GPT-3. The International Energy Agency projects that AI data centers and crypto requirements for electricity will be 800 terawatt hours in 2026. That's 75% more than 2022. The companies that need that kind of power are buying nuclear reactors. A nuclear reactor near you. I wouldn't be surprised if Plant Vogtle doesn't end up powering AI sometime. I'm not sure that they shouldn't. I'm just saying that they're using these small reactors that have either been deactivated like 3 Mile Island or can be used just for a small purpose, small modular reactors. But the amount of power that's going to be required is going to take an offline additional power source in order for these companies to maintain this level of compute power. So all this, as you might guess, has begun to lead to scientific concerns in the AI community and outside of that community. When Jeff Hinton left Google in May of 2023 to go, he spoke to the New York Times and said, look at how AI was 5 years ago and how it is now. Take the difference and propagate it forwards, like Leopold did. That's scary. He's just looking at the data. He's a scientist. He's not getting paid to be, a spokesperson for anybody anymore. In May 2023, the US Senate had hearings, listened to Sam Altman talk about OpenAI regulation and called it crucial. But if you look at the OpenAI statement on AGI, it kind of vaguely states that yes, we should be cautious and looking for ways to review and ascertain the rate of growth and to make sure we're not growing too quickly. OpenAI just closed its quality control unit. And the guy that ran it for 10 years just left because he said, they've taken everything away from us. We have no capacity to do what the statement there says. I can't do this anymore, I'm leaving. That's ethics, okay? He said, I'll go to the community, I'll go into the public sector, I'll do something to help somebody, but I can't be part of OpenAI's attempt to take away the functionality of the very unit that I created 10 years ago to help them to be an ethical organization, right? Quickly, AI reality meets medical practice. In this AMA, American Medical Association survey, they asked physicians if they are using GPT in their life, in their professional life, and you can see that 72% said they were not using it at all, and in personal life, 62% said they were not using it at all, but a significant number were using it occasionally or frequently. So physicians are starting to play with this a little bit. Respondents who are tech-averse versus tech adopters are listed here. You can see that 37% of this survey said they usually incorporate new technologies when my peers do. Some of them, 32%, are ahead of their peers, and some of them are early adopters. It's great to be interested in a new technology. It's great to want to adopt it. It's important to be sure that it is safe in your hands as well as in the hands of your colleagues before you adopt it. The American Medical Association is an advocacy group for physicians. It's our lobbying group, right? They're the ones that lobby for us to be paid more, for us to have more power, for nurses to be disempowered. Sorry, that's true. And so all the things that it does, it thinks it does, and what it's doing here is weighing in on this controversial issue of ChatGPT or other generative AI in clinical practice. I wrote this article in 2019, and I think it outlines for me, and for me at that time, and still, the ethical responsibilities of physicians, nurses, and other health professionals. So I put physicians here, but it could be any health professional. First of all, and this is not in any order of importance, you should be willing to lend your knowledge, domain expertise to computer scientists who are trying to design systems to help you. If you won't lend your domain expertise or won't review the papers that come across your desk, right, sort of thing, then you are not doing anything to help them build better rules-based or machine-based models. You're not helping them with their decision steps, creating causal inferences for predicting future outcomes. You've got to understand the field to help them to figure out what they're working towards when they're programming. Otherwise, it's just random, monkeys at a piano kind of thing. I mean, not quite that bad, but I mean, they don't know. They're better with somebody there. Secondly, you should have some AI literacy, if nothing else, to help explain black box predictive models to patients for genetic testing in hospital events. And I think if you have AI literacy to a degree, you reduce physician-patient disintermediation. In other words, you reduce the chance that a technology is going to get between you and the patient, okay? If you let technology get between you and the patient, that's called disintermediation, and I don't think patients like it when they're cared for by a technology. They want to talk to their doctor. They want to see what happened, what's going to happen, and I think that's important. You have some ability to explain what's going on with them. Be aware of data provenance. Does data quality impact model scalability, reproducibility, accuracy? I talked to you about the ophthalmology model. It's also important to know that a lot of the data that was used to train those current applications that are out there, FDA approved, were data that were captured prior to 2021. They may not be the current best training data set for 2024, 2025 applications. So stale data is not always the best data. And then finally, It's good for all of us to get involved in data inputting, quality assurance, whether you're data wrangling before the modeling takes place by helping to enter and curate data sets, or you're looking at post-market release quality coordination per the FDA directives that I'll show you next. But you've got to be engaged to some degree to be able to make a contribution of a positive nature. When the FDA approves a narrow medical AI device or a software as a medical device, it goes through model training, data detection, looks at your feature engineering, looks at your tuning, and validates your model, and then it says you can sell this product, your watch for detecting atrial fibrillation, for example. What you don't hear much about, and what they aren't able to do, is do the post-release review of the model's performance in the real world. Now, they're told they have to. It's part of the deal. When you get your approval by the FDA, you agree to the green box. After model deployment, you agree to collect data, and if there's performance problems, you have to change your model, re-engineer it, and report it to the FDA. The FDA cannot police that. They are not set up to do that. It would be wonderful if they could. Nobody else exists to do that. So it falls to the companies themselves to take the time, energy, and resources to re-engineer something that they're selling and say, this could be better. We have to fix this. It's our ethical responsibility to do that. They're trying to make money. They're mostly for-profit organizations, right? Healthcare use of large language models is risky, whether you're in the United States or Europe. The following words exist. Large language models in healthcare carry unacceptable risk, especially as the EU AI Act illustrates, but they remain unregulated in both the US and Europe because they're not high risk. They parse the risk here to say that while we're concerned about them, we can't regulate them because they're not high risk. So large language models, number one, are not regulated in either the United States or Europe. Number two, they're subject to tort liability, medical malpractice liability. If you use one in practice and it causes a patient harm, the US Department of Health and Human Services has determined that you will be subject to a lawsuit if you do that, if it creates access discrimination for different racial or ethnic groups, or you action questionable information or disinformation. Finally, you've heard of HIPAA, Health Insurance Portability Act, right? HIPAA is what's supposed to protect our personal health information, our PHI, from being sold or released or not properly handled. That's why all your medical records go on the fax machine. Just kidding, they do. But anyways, the large language models are not subject to HIPAA, so therefore they're not required to be HIPAA compliant. I once tried to make a product that we had put together HIPAA compliant. It's a thing. None of these large language models are HIPAA compliant. So if you give a large language model personal information, God forbid health personal information, it will find its way into the information universe because it's not restricted and there's no penalties for you doing that. Now, I made this slide yesterday and I was worried enough about this whole topic before I made this slide, but when I finally put this to paper, I said to myself, so to speak, this is even worse than I thought because we are creating an environment where profit-driven large language model creating companies who are venerated for their innovation, venerated for their share prices, venerated for their creative CEOs, have no controls. It's the Wild West. Back to history. Earlier this year, John Hopfield and Jeff Hinton received jointly, 0.5 each, the Nobel Prize. They do parse it down to percentage points. And they basically got it for the same thing. For machine learning of image patterns within artificial neural networks, for creating the Boltzmann machine, which can learn to recognize a characteristic element in a set of data to classify primarily images, right? So they were the first multi-layer, discriminative classification algorithms that were shown to be accurate, and that was 40 years ago. There's been better stuff done, you could argue, since then, but the seminal idea back in 1982 was using a multi-layered feed-forward network to take many inputs, and narrow it down with math to one or two high probability outputs. Whether it's ciphering things or looking at an image and saying it's a panda, not a gibbon, whatever it is, that's the magic of what they created. And it's a form of physics, so they got the Physics Nobel Prize. It is election day. I had to put this slide in also yesterday. So in the present day, according to this MIT Technology Review and other Economist articles from 2023, we know today that AI is causing deep fakes, avatars, videos, audios that are not real. We know that it is causing foreign disinformation threats. It's causing AI opinions to swamp human preferences. It is doing bad things already. The future, and they speculate, but this is not entirely speculative, you could have a Manchurian AI candidate. You could have generative public testimony being accepted by governments as being real. You could have generative legislation passed into law. You could have AI pollsters beating human consulting firms in polls and other measures of elections. You could have AI creating a new party and a new party platform, de novo, generative party. You could have AI doing auto hustles and contributing money to campaigns because AI can raise money, right? Autonomously, it can raise money. There are tools that you can use to raise money with AI. And finally, AI coordinated policy across multiple jurisdictions for taxes, for regulations. AI could be used as the coordination vehicle for doing that across the European Union or NATO, whatever it might be. And that all is possible in the future. It's not in the articles, which you can read. It seems quite reasonable. So it's scary today, could be different tomorrow. In our political process, might never be the same. All right, so I'm going to finish with the last two slides here. For AI to work, physicians and patients have to trust it. Now, when we wrote this article back in 2018, we said this: the daily practice of medicine is a game of sorts. AI was not specifically developed as a tool for healthcare, and while AI is poised to address indirect medical practice pain points, it is neither astute nor intuitive. Humans will remain essential to the intelligent use of AI in medical practice. That's still true. It's 5 years old, it's still true. 6 years old now. It's important that we all kind of come up with our own belief system for how we're going to use this technology, or structure for how we're going to think about it. I thought about this a lot yesterday, and my current take is the following. Willingness to adopt AI is not the same as individual or organizational readiness to use this potent technology responsibly. Willingness to adopt is not the same as readiness to responsibly use. That's my ethical principle now. I'm guided by that. Excitement is wonderful. Playing around with something is great. You bring it into the workplace and start using it at whatever you do, and you can use it as an educational tool, for example, as you were discussing at lunch. But bear in mind that that willingness is not the same as being ready to use it in a responsible way. I'm going to start proposing this. To assure patient safety, state medical licensing agencies like Georgia require postgraduate continuing medical education, certification, credentialing, and all the things listed there and more. Why aren't we being credentialed in AI? Why wouldn't, if we're going to use it in a medical setting, why wouldn't you want to credential physicians and nurses and care providers to be able to use it responsibly? It's not occurring. It's a new idea. Don't steal it. But at the end of the day, I think we have to, if we're serious about it, and all you're hearing is, oh, we're going to use it in healthcare, we're going to use it in medicine, it's going to be great. Well, yeah, so what are you going to bring to that? There are issues here. You have to understand them. So that was it. Thank you very much. I appreciate your time and happy to answer any questions. Thank you.
You know there has to be questions. I'm sorry? Yeah, oh, no. No, there has to be questions.
Or they're answers. It could be answers. If you want to go down there, Kathleen.
So I just had a question about how you said that patients prefer that they like to hear medical advice from doctors, but recently, AI companies such as Character AI, for example, people are generating these avatars like therapists and people who struggle with mental health issues. They tend to turn to those
Yep.
avatars to help them talk through their problems. And I was just wondering what you thought about that.
Yeah, that's a great question. I hope everybody heard it. So in certain types of medicine or healthcare, mental health being a great example, patients have conditions that make them a little distrustful of human caregivers, physicians, nurses, whatever they may be, right? And they become comfortable with an avatar, a representation of a caregiver, where they can have a protected and helpful conversation to address some of their concerns and feel like they're just a little bit lower anxiety, if you will, in terms of the interaction. I think it's a great idea. I think the chatbot-driven mental health industry, though, is scary. So you got to find the trusted, medically overseen avatar that's always being watched and quality assurance is being tested, and the chatbot that's just giving you whatever they got. Yeah, okay, I understand you're anxious. Why don't you take a run around the block? I mean, I'm really anxious. I'm trying to kill myself. Well, just do go around the block twice, yeah. So, so you have to be careful. But yeah, that's perfectly fine. There's nothing special about physicians, by the way. I don't want to give the wrong impression. Caregivers of any sort, right? Professionals that provide care, nurses, whatever it may be. Patients really do still value talking to a human being about their condition. So best example I can think of off the top of my head is one of my colleagues, Dr. Kapoor, is an interventional cardiologist who opens vessels that are closed and nobody else can open. And he's very good at this. He's very quiet. And after every one of his complicated 2-hour procedures, he makes a point of going to the patient's bedside still. He's a technician in a way, and he makes sure that they understand what happened, how they did, and that they have any of their questions answered. And he doesn't have to do that. And in a world where technology is powerful, and he used it and made the result that he wanted, he doesn't have to do that. So I think we as professionals in any field always feel better when somebody like us comes to the source of the discussion and has a question or answer period. Yeah. But that's a good question. Thank you. What field are you in? Good for you. Congratulations. Yes.
Hi, thank you for the talk. It was very interesting. Outside my scope, I'm not in the medical profession. I'm a lawyer. And we, as a profession, are generally very resistant to AI. I don't know if you've heard, but we're trying to regulate it out of our field in a lot of ways. So
Yes,
I'm
sure.
not sure if that's right, wrong, or whatever. I have a question about your recommendation at the end, mentioning that you think you guys should credential or have credentials in AI. Do you see that embedded in med school curriculum? Would you see that? Would you recommend that embedded in other professional curriculum for the betterment of all the professions?
Yeah, so we developed a healthcare and medicine course at MCG in 2020, and highly subscribed by medical students and other health profession students. Certainly was not even in the era of generative AI really as being a common discussion point. I think there should be some curriculum in all areas of higher education and postgraduate education that looks at the impact of this technology on your field. I think everybody should have a core understanding, that literacy about what it can't do, and then they should say, in our field, it's particularly important because of this or that, right? I think if you just have a general understanding, and then what about us? How would we misuse, or misunderstand this powerful technology? I think that would be good at an educational level. I think if you've got licensing bodies that are involved, like medical licensure bodies, for example, or legal licensure bodies, boards, those should also require a recurring, improved and updated level of understanding as that field and its impact on the practice of whatever is evolving, right? What's the greater risk to patients right now? I'm being a bit facetious. I don't know how to do CPR, or I don't know how to use AI intelligently or safely. Right now, it's probably, I don't know, if I didn't know how to use CPR, that would be a bad thing. But in 5 years from now, when we have AGI, that would be maybe more dangerous in a setting which is uncontrolled. how do you use narcotics responsibly? Remember, we used to think about not using narcotics the way we use them now, all the things that could be. So I just think it's a wide open field. And I did some research on this, and it's not part of anybody's state licensing board. So we could, let's beat everybody. Greg.
As you were talking, I was reminded of the CRISPR's Cas9 gene editing technology, and within the last decade, and the debate that we had over that, and the public concern about the technology. And it kind of reminds me of this, but for that, we had a moratorium on human experimentation while we were having the discussion of whether we should be gene editing at all. Any thoughts on that and how that relates to what we're doing now?
Well, there is a large number of AI scientists who've signed a letter, which I signed too this week, just to be supportive. Doesn't matter. But that says you should be stopping generative AI research. It should be held until we understand what we are doing. There needs to be a pause, at least. And these are powerful people like Hinton and other, Bengio and other people like that in the field. And that reflects a very high level of concern by knowledgeable, invested people in the success of AI, that we've got a technology that's out of control. And we've got difficult motivations to understand in the companies. The companies have all eliminated their units that provide any kind of internal control. If they haven't been eliminated, they've been neutered, so that they don't have a seat at the table when decisions are being made. It's so pervasive that you would have to have a pause, and that's what these people want, both in Europe and the US. But I'm afraid it won't happen. I just think the power behind the engine is too great. It will take a catastrophe. That's how we learn as humans, right? We either preemptorily do something that's wise because we're supposed to be smarter than other species, or we have a disaster. So I remember I went to a conference at Stanford before COVID, and I presented a paper on AI in education, and I was surrounded by people from the defense industry. I was the only person in this size room with this number of people that wasn't from the defense industry, it felt like to me. And they were all talking about the quality of data that they were getting in real time to decide when they could release a weapon system to its own devices. How close do you have to be to the target? How much visualization do you need? And how much confidence do you have in your AI to give over the technology to a killing machine? And how many of you have seen Ender's Game? Okay, so remember they're training the kids, and the leader of they're fighting the buggers, and they are in a massive conflagration of a battle. And eventually they have to give Ender control. And that's what the defense industry lays awake nights worrying about. When do we give Ender control? I'm afraid that what's going to happen is that Ender's going to take control someday and nuke someplace that we didn't want to. I mean, the Israelis could overshoot the area that they weren't trying to bomb, the refineries, the nuclear plants in Iran. They just wanted to take out the barracks, right, and the other places where the defenses were. But what if the machine just said, I like this solution. I like this idea. I can get there. I can do that. The defenses are down. Click, and in they go. And that's when we're going to learn. And we are humans. Sometimes we need hard lessons to learn. So I think that's where we are with this technology. But better informed humans vote more intelligently. Better informed humans use technology more intelligently. And our ethical principles, to get back to the purpose of this, as leaders, as we are in our fields, are to try to have an understanding, an ethical framework for what you're seeing and doing, so that you don't inadvertently create enthusiasm over robustness, or whatever kind of paradigm you want to put together. So, anyway, good question. Yeah. Yeah, sure. I can hardly wait to get back to Monticello. There's lots going on there, as you can imagine. I plan to stop and spend a few hours there. Yeah.
Is it correct that the bigger issue, or to me, the bigger issue is that the AI is learning from what you're telling it? Not just what it learned over here when it was built. And so if you're telling it, I'm depressed today, in 10 years, somebody's going to say, Liz Riley was depressed, maybe we shouldn't hire her, or maybe her child is going to have a problem. I mean, that to me is the bigger issue, is the fact that everything we type into AI right now is becoming a part of AI.
Yeah, that's a fair concern. Whatever interaction you're having with any kind of AI, chatbot, GPT, never give it any personal information, because it will not be protected, and it could resurface in ways that you, just like you may have pictures of yourself you don't like from Google searches, right? I mean, yes, I did wear that outfit at a Halloween party, but at the end of the day, it's in the universe of discoverable information, and it also can be learnable information. And I think the project that Mark described over lunch is the importance of how the query is framed safely determines the quality of the response. A well-framed query to GPT is met with a low hallucination, better response. GPT average response is about 81 words. The other models that are out there are in that range. Some of them are, like Palm 2 is 221 words, which is too long. It just enhances the potential for hallucination within that flowing text. But anything that you give it, it's got. So if you have a mental health problem and they say, we're HIPAA protected, well, the technology isn't. Your company may be, and you may think that you can fool people by saying you're HIPAA compliant, but the technology isn't encapsulated in just your company. It's available beyond those boundaries eventually, so, or if your company is purchased, all those things, right? So it's a fair concern, yeah. It's a, I mean, I can't think in my mind, maybe you can, you should maybe think about this, is I can't think of a more powerful technology that is getting so much more powerful by the minute, that is unregulated and so poorly understood in real world applications, right? I mean, the folks that write the papers and do the tech and build the systems are just regular people. One of my best friends is the guy that invented the encryption system for WhatsApp. And he's really happy that you can send messages that are end-to-end encrypted. He made that, right? He didn't know that ISIS was going to use it. He should have, maybe, but it didn't mean he shouldn't develop the technology. It's up to us to decide when things are used for good, bad, or in the gray zone, how do we work with that? And people need mental health support. They don't have enough mental health professionals out there to support them, just like they don't have enough people to screen for diabetes in India. But when you introduce a tool that's supposed to help them, do no harm. You have to be careful about that. So, all right, well, I'll let you guys get back to voting. Thank you again, Mark, for the invitation.
Thank you very much.
Yeah.
And thank you all for being here. And if you're a student or faculty, please register your attendance. I've got a QR code out on the outside there. You can just pop it real quick. It'll ask you for your name and your ID number and a whole bunch of other little bits of information that we will use. I'm kidding, but I certainly think that we can thank Dean Miller. He makes all of us Dean Millers look a lot better. So thank you very much for being here today. And Renee, I'm going to let Renee, hold on one second, one last thing. I'm going to let.
Hi, everyone. You all got an email from me earlier today, but I'm Renee Rainey. I'm the general counsel here at the university and sort of with the committee in charge of Ethics Awareness Week this year. And so we have another event tomorrow afternoon. It'll be a very interesting panel discussion. 2 students, the president, Dean Billy Wooten, and a community member. It will be in Cochran at 3 p.m. Tomorrow afternoon in Alderman Hall. So we encourage you to also attend that event. And if you have counterparts in Cochran, tell them to please attend that event. It'll be great as well.
Thank you.
Thank you.
Thank you all. You'll have a great afternoon.